This lecture introduces the solar wind, which will be discussed more in the Space Weather Learning module. The goal is to be able to describe solar wind. The solar wind is the streams of charged particles, mainly protons and electrons, flowing continuously away from the sun in all directions at speeds of 300 to 800 kilometers per second, approximately 1 million miles an hour. The heliospheric current sheet results from the influence of the sun's rotating magnetic field on the plasma in the interplanetary medium. The wavy spiral shape has been likened to a ballerina skirt. The heliospheric current sheet extends to the outer reaches of the solar system and results from the influence of the sun's rotating magnetic field on plasma in the interplanetary medium. In 1990, the Ulysses probe was launched to study the solar wind from all latitudes. All prior observations have been made at or near the solar system's ecliptic plane. Ulysses provided unique measurements of entities in solar wind, a topic we'll cover in greater depth in lectures about space weather. Ulysses discovered that the sun's magnetic field interacts with the solar system in a more complex fashion than previously assumed, that dust coming into the solar system from deep space was 30 times more abundant than previously expected. The magnetic field emanating from the sun's poles is much weaker than previously observed, and that the solar wind has grown progressively weaker during the mission. It is currently at its weakest since the start of the space age. The observed long-term trend of lower dynamic pressures implies that the extent of the heliopause, the solar system's buffer against galactic cosmic rays, has been shrinking. The solar wind drags the sun's magnetic field to create a huge bubble, many times larger than the orbits of the outermost planets, and defines the extent of the sun's influence. The interplanetary magnetic field exists throughout the heliosphere. It is formed by the radially expanding solar wind that drags the solar magnetic field outward to the boundary of the heliosphere. Solar rotation winds the field lines down of force into a spiral. The heliopause can be considered the boundary of the sun's influence and is the location where the interstellar magnetic field dominates the interplanetary magnetic field. There are 5 interstellar probes: Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons on interstellar trajectories. As of 2015, Voyager 1 is the only probe to have actually reached interstellar space probe to provide an SITU measurement of the heliopause.